Hello, my name is Chuck. I'm with the HART Communication Foundation. We're at the ACHEMA display, ACHEMA trade fair here, and this is the HART technology display. What the display points out here is our theme being Get Connected. We're actually displaying in different ways that you should get connected to the intelligence in your HART field devices. HART is the leading communication protocol in the world with over 35 million installed devices. Our members tell us that the majority of the devices shipped every year are HART-enabled. Therefore, it has the opportunity for you to start communicating full-time with your devices in order to get the maximum benefit of your asset. Now, HART is a very simple, reliable, and interoperable technology that makes it perfect for the process industry. Because of the different types of industry, different skill levels, we wanted to keep it as simple as possible. Again, HART is kind of like the de facto standard, and we want to also make sure that they're interoperable, meaning that you can simply buy any vendor's device and attach it to any system. So they all work together. As you may see on this display here, there is a variety of different devices, all different shapes, all different colors, all different suppliers, and they're all working together in harmony to allow you to make sure you get the full benefit of your devices. Well, let's talk here a little bit about taking a device out of the box and getting it set up for HART. Now, one of the big differences that the HART communication protocol offers is that it's both analog and digital. Meaning that there is the analog 4 to 20 milliamp signal that everyone is used to in our industry. It's an industry standard. And on top of that analog signal is a digital wave, as represented here in our big graphic. We have the digital signal superimposed on the analog signal. This is a simple example of that. Everyday use is on your telephone system, where you have your analog, where your voice is going on the analog wire, and yet the caller ID on your telephone is the digital signal sitting on top of that. So in reality, everyone uses a type of kind of HART communication on an everyday basis at your home. So what we have here on display is an easy way to actually see the analog and the digital. If you look at the digital panel meters, you will see the analog, or the 4 to 20 milliamps being displayed that's available on each of the wires. 7.14, 12.02, and 8.12 represents the milliamp level being available on the wire. You'll also notice red flashing lights up there by the HART logo. The red flashing LEDs indicate the digital part of HART, which is the digital packets that are being communicated on the analog wire. Now, we've also added a special feature on this display that allows you to hear HART. So now not only are you able to see the analog and the digital, but if we turn up the volume here, we're going to be able to actually listen and hear HART, actually hear the HART modem. As we can see, it is directly related to, in this particular example, connected on this wire, connected to this particular device. So there, again, there's an example of being able to see and hear HART technology. So when you first get a HART device, it's important to configure the device to make sure it's suitable and applies directly to the application. And there are several ways to do that. One way traditionally is with a handheld configuration tool, and there are several of those available on the market. And again, since HART is a totally interoperable and open technology, a tool of this type or any of the other types are able to configure any devices made by any supplier. In addition to a handheld device, there's also PC-based application tools that'll allow you, using a modem, a HART modem, to be able to connect to a device and actually get a visualization of what you actually are configuring in the device. And by configuration, we're talking about adding the instrument tag, setting the zero and span, setting the engineering units, and all the other information required by a device to know how it's going to be used in the application. Okay? Once we go from the instrument shop where the device is configured, we move into installing the device into an actual operation. When you install the device, you can install simply by using the standard 4 to 20 milliamp wiring. But in a lot of cases, that allows you then to speak to the device using HART technology on a point-by-point or as-needed basis. That's okay, that's fine, that's done in many applications, but you're not getting the full benefit of the HART technology that you purchased in your device. In reality, the best possible solution is to have a so-called HART-enabled system where the system is able to speak to a HART device full-time. Well, we all know that the majority of the systems today do not necessarily allow that capability or flexibility. So what has been created over the years is a variety of solutions on the market that will allow the 4 to 20 milliamp signal coming from the device to be able to be passed through onto the analog control system. So we're talking now about control systems that are not HART enabled, that are just 4 to 20 milliamp based, and yet you still want to be able to come in full contact and full use of the HART data in your device. In this particular case, and in several of these other examples, these are multiplexers where, again, the analog signals will come in, the analog signals come out untouched into the standard control systems, but yet we have the capability of lifting the digital signal off of the 4 to 20 milliamp wire and be able to send that information to, say, an asset management system to give you full-time access to that information. Why do you need full-time access? Well, all HART devices on every communication includes, for example, 6 status bits. And those 6 status bits can easily be used to give you a quick diagnostic sense of reliability or quality of the information being communicated from the intelligent field device. Again, these intelligent HART-enabled devices have a lot of information, a lot of capability, even a lot of different variables. In addition to the main process variable, you're able to allow a secondary, third-level variable, fourth-level variable to be communicated to the control system. So, for example, a pressure transmitter can also be made to communicate a square root signal or the temperature inside the device to give you some secondary measurements to help you with diagnostics or give you the confidence that the device is working properly. In addition to the multiplexers idea, we have several on display here. These are designed to enable you to take multiple signals and being able to communicate them into a host system, still on an analog basis, and to be able to give you still access to the information in your intelligent device. We also have other capabilities where on a single point-by-point basis, we're able to take just a single device and be able to allow the analog signals to continue to come in, and then the analog signal, the device will read the analog signal and the digital signal. It will convert the digital signal into several analog signals. So again, if your system is only analog based, you're able to now take these variables that are in these intelligent devices and create multiple analog signals representing the different measurements inside these smart devices. So on a point-by-point basis, or in a case of multiple points where you want to access multiple devices, we have all kinds of solutions available today to make it easy to give you full-time access to your HART device. Moving over further down our display, we get into the capability of remote I/O. Remote I/O is a technology that allows now, again, multiple devices to be able to be tied to the remote I/O system. The system here now conditions the signals and reads the HART data, conditions the 4 to 20 milliamp signal, and then communicates directly to the host via Ethernet or some other high-speed type protocol. So in this particular case, the wires don't even have to be run back to the central control room. This remote I/O system can be located out in the field, and instead of running 100 or 200 or 500 pairs of wires back to the control room, it's simply running one Ethernet cable or fiber optic or some other protocol back to the control room, which makes it very cost effective. If you're also running into a situation, like in most plants, where there are very few spare wires or limited number of wires available, and you're always faced with the problem of adding new measurements to your system, we also have a wireless solution. So HART runs the entire gamut from wired to wireless. So this part of our display now is dedicated to the introduction of the wireless HART technology. Wireless HART is HART, but delivered instead of on an analog wire, it's delivered on a wireless basis. And the system and the technology applies to both a full dedicated wireless HART device, as we see here, or on an analog 4 to 20 milliamp device that uses a wireless HART adapter. A wireless HART adapter, such as this one, can be attached to your standard analog, traditional HART-enabled devices that you're using today, that you have in your inventory today. And by adding a wireless HART adapter, you're able to take the information from these intelligent devices, the process variable, as well as all the secondary, third level type variables, and all the HART diagnostic information in your device, and be able to communicate it wirelessly to an actual gateway. So the two main components of a wireless HART system are the devices. And again, the devices can be like a battery operated device with native wireless HART built in, or an analog device using an adapter of different types. There are multiple suppliers of these wireless HART adapters. They come in battery types, they come in, other types use the 4 to 20 milliamp power that's available, and actually are powered by the same 24 volt power supply that's used to power the devices. They are then communicated to a gateway. In our example here, we are showing a gateway now communicating to these devices. In the wireless HART topology, you can either have devices that communicate directly to a gateway on a point-by-point basis, or use the mesh network where the information now is being passed on from device to device, so that the actual distance from the device to the gateway can be extended. Again, the question isn't necessarily how far can a device be from the gateway. The question now becomes how far can a device be from the next device, because the information is kind of relayed from device to device, allowing you to extend the network. Wireless HART technology has been evaluated now in more than 8,000 networks around the world, and has been proven to be simple, reliable, and secure. We hope we've given you a little information here, and we certainly thank you for stopping by the HART Communication Foundation stand here and seeing and learning about all the different ways that are now available to you to get connected to the intelligent information in your HART device. Thank you for stopping by.